Chapter 1, the where, why, and how of data collection. In this video, we will learn how to categorize data by type and level of measurement. Here we have a diagram that displays the different data types and data measurement levels and how they relate to one another. It's important to know these because the starting point in analyzing any data is to first understand what kind of data you have, because that will determine the process that you'll use. So let's first look at the different data types. Quantitative data is inherently numerical, so we're dealing with numbers. And in chapters 5 and 6, we'll talk about discrete numbers and continuous numbers. The other data type is qualitative, so these are categorical. Examples would be marital status, like married, single, or divorced. Other categories include political affiliation, like Democratic or Republican or Independent, or even eye color, like brown, black, blue, green, and so on. So qualitative data are not numbers related. Think quantitative or quantity of numbers, and qualitative or quality, where there's some attribute or category that's related. Other data types we should be aware of are time series. So this is a set of consecutive data values that are observed at successive points in time. For example, if you followed the stock market on a daily basis. Then there's cross-sectional data. So this is a set of data values at a fixed point in time. Think of it more like a snapshot in time, like when you take a picture. So the example here would be bank data about its loan customers. In this example, we've got sales numbers for 4 different cities over 4 different years. So we've got circled sales numbers for Atlanta, and that would be considered time series data because we have data from 2009, 2010, 2011, and 2012, consecutive points in time. And so we can see how sales have either gone up or gone down over these 4 years. However, if we look down the column for 2009, this is considered cross-sectional, since we're taking a single snapshot to just look at 2009, but over multiple cities: Atlanta, Boston, Cleveland, and Denver. Again, think time series is a series of time periods and cross-sectional is a single snapshot in time. And you can have both in the same set of data. With data measurement levels, there is an order from low to high, in that the lowest level, you're limited to the kinds of data analysis you can conduct, all the way up to the highest level. For these types of data, you can do all kinds of data analysis. So the first and lowest level is nominal data. So in other words, these are categories, labels, or names. For instance, categories could be gender, your major, your marital status. Theoretically, these labels or names are equal to one another. There's no one name or label better than the other. Next is ordinal data. So it's similar to categories, labels, and names, but now there's a rank or order to it. So we have ordered categories or some kind of scaling. This can include satisfaction ratings, or for instance, rating pain on a scale of 1 to 10. You cannot measure ordinal data. I use the pain example because, for instance, my idea of a 10 in pain might be very different than your opinion on what a 10 in pain feels like. We can't measure it because we're just sharing our feelings or ideas about it. So these two levels of data are considered qualitative. Now, our third type of data measurement level is interval data. This type of data can be measured, but it has no true zero. So for instance, the most commonly used example is temperature, where there's no true zero. Because for instance, if I told you it was 0 degrees Fahrenheit outside, you know that it means it's really cold, that there is something occurring at 0 degrees. Or for instance, if we think of the time of day, if I say it's 0 o'clock, it doesn't mean the absence of time because it doesn't have a true zero, but rather we know that 0 o'clock means midnight. Lastly is ratio data. This is measurable data and a true zero does exist. Examples here would be height, age, or salary. So 0 height would mean I can measure something and it can start at 0 inches or centimeters or whatever unit of measure you're using. In regards to age, We can have a 20-year-old person, a 1-year-old person, or even a newborn baby at 0 years. They were just born. With salary, you can have a true $0 salary, meaning you don't have a salary, or you're working for free, like an internship, for instance, or volunteering. Thus, these two data levels are considered quantitative. So there are numbers involved, they are measurable, but the main difference between the two is that the interval data doesn't have a true zero, whereas ratio data does. So let's do a quick check-in. When you're given data like this, the first thing you'll want to do is identify the different variables in the set. So we'll start in column A and look across at the different columns. So we can see that we have 13 different variables, starting at column B and on. Now, in the textbook or in certain books, sometimes they consider the column A as a variable, but I don't. I consider it more as an identifier. I can't measure or count how many Adelphi universities there are, so I really consider this more as an identifier. Whereas the variables that I'm going to count, measure, make charts from, analyze are the columns here to the right. Next, you want to figure out, is this time series or cross-sectional data? So for instance, when we look at this data, do you see anything that lets us know that there are multiple time periods going on? There's no mention of any years, months, hours, dates, anything related to time. So we can assume that this is cross-sectional data, even though it's not specifically labeled that this is 2018 data, for instance. The next step is to determine which variables in our data set are quantitative or numeric, and which are qualitative or some kind of quality. So if you notice in column B, the state is a label or category, so this would be considered nominal. When we look at column C, it's a bit tricky, but as you can see, public and private are the labels. It's just that they've been given a code or a number to identify it. Thus, our columns A, B, and C are all considered categorical or qualitative in nature. And the data measurement levels here would be nominal. Now, there's not a whole lot you can do in terms of analyzing this kind of data. For the most part, you can just count and make graphs using this information. But if you look to the right, we see SAT scores, application numbers, number of enrolled students, number of full-time and part-time tuition, percent of faculty with PhDs, and the student-to-faculty ratios. These are numeric, so we know it's quantitative, and because they're measurable with a true zero, we can see that these are also ratio level data. Because you could get a 0 on your SATs, there could have been 0 applications received, or 0 new students enrolled, or tuition was $0. You could have a true 0 in any of these cells here. Again, ratio level data is the highest level, meaning we can do all kinds of data analyses with columns D through N. And as we move forward into the other chapters, you'll learn the different ways we can analyze all of this data. So if you have any questions, just let me know.